All right, so we did a soil evaluation by auger here, and we're interested in the three-dimensional properties. So the best way to evaluate a pedon for soil classification is to actually look at the pedon from a pit, which is a hole in the ground. Luckily here in Crop and Soil Sciences, we got this John Deere 485A attachment here to dig us a hole. So Ruben here in a second is going to demonstrate how we dig a pit, which is our nice hole in the ground, and then we'll clean it up and discuss the properties that we're seeing. Our work. So let's check out the soil bed. The major advantage of a pit, when you can dig it and you have a backhoe that can do it, and you're in a situation where it's dry enough to do it, is you can see the three-dimensional representation of the horizons and the boundaries. And so you can see here we have very pronounced horizons. The surface horizons are completely different than the subsurface, and so this qualifies as what we call a buried soil. So we have relatively recent HTM, or human transported materials, and the reason I can tell it's human transported materials is it's all mixed up. There's coarse fragments, there's these zones of really red clayey material, which is subsoil, and then there's these other zones of sort of brownish material, which would have come from an A horizon. So HTM is very commonly mixed. It's mixed horizons, and so this is how we can tell human transported materials. And in this case, it's obvious that we have something crazy going on because we're high on the landscape, and so we don't expect geologically anything in North Carolina to come up here and deposit new material on top of this buried soil. This is not a landscape position. We're essentially on the upper back slope here. There's no way that this is colluvium because look at the color of the underlying soil. It's much yellower than the red material on top. So this red material came from somewhere else. People moved it here, dumped it on the landscape, and then buried this really pronounced A horizon. So we have a APB, and then under that we have an E, a really nice zone of eluviation down here, EB, and then below that we have a BT, B, and then below that we have saprolite, which is our residual material that is weathered in place, and you can see in places remnant rock structure sort of coming up in the direction towards me, and that's a really good indication that we have saprolite. And the other thing you can see if you look at a hand sample down there is a lot of primary minerals. So you'll see a lot of micas and other geologic primary minerals that haven't weathered out to form clays, as is in this yellow horizon or BT horizon that's buried above. So this is a very distinct soil where you can tell that this soil, this used to be the surface, it's been buried by some process. That process is human transported materials. We would put a caret, we'd have like a caret A, and then I'll just call this a caret C. It's not undergone enough petagenesis to make like a BW horizon yet, and it's still all mixed up. You have these different sections of different material that's all jumbled up in here. Over geologic time, this will eventually form a B horizon, but it's not been on the landscape long enough to do so. So this is a very good example of, if you see something weird in an auger, and you got the luxury of digging a pit, it gives you further information about what's going on. Human transported materials over a buried soil underneath.